Passive fire protection, PFP, is an integral component of the three components of structural fire protection and fire safety in a building. PFP attempts to contain fires or slow the spread, through use of fire-resistant walls, floors, and doors, amongst other examples. PFP systems must comply with the associated listing and approval use and compliance in order to provide the effectiveness expected by building codes. The aim for fire protection systems is typically demonstrated in fire testing, the ability to maintain the item or the site to be protected at or below either 140 degrees Celsius for walls, floors and electrical circuits required to have a fire resistance rating, or 550 degrees Celsius, which is considered the critical temperature for structural steel, above which it is in jeopardy of losing its strength, leading to collapse. This is based, in most countries, on the basic test standards for walls and floors. Smaller components, such as fire dampers, fire doors, etc., follow suit in the main intentions of the basic standard for walls and floors. Fire testing involves live fire exposures upwards of 1100 degrees Celsius, depending on the fire resistance rating and duration one is after. More items than just fire exposures are typically required to be tested to ensure the survivability of the system under realistic conditions. To accomplish these aims, many different types of materials are employed in the design and construction of systems. For instance, common endothermic building materials include calcium silicate board, concrete and gypsum wallboard. During fire testing of concrete floor slabs, water can be seen to boil out of a slab. Gypsum wallboard typically loses all its strength during a fire. The use of endothermic materials is established and proven to be sound engineering practice. The chemically bound water inside these materials sublimes. During this process, the unexposed side cannot exceed the boiling point of water. Once the hydrates are spent, the temperature on the unexposed side of an endothermic fire barrier tends to rise rapidly. Too much water can be a problem, however. Concrete slabs that are too wet will literally explode in a fire, which is why test laboratories insist on measuring water content of concrete and mortar in fire test specimens, before running any fire tests. PFP measures can also include intumescents and ablative materials. The point is, however, that whatever the nature of the materials, they on their own bear no rating. They must be organized into systems, which bear a rating when installed in accordance with certification listings or established catalogs, such as DIN 4102 Part 4 or the Canadian National Building Code. Passive fire protection measures are intended to contain a fire in the fire compartment of origin, thus limiting the spread of fire and smoke for a limited period of time, as determined the local building code and fire code. Passive fire protection measures, such as fire stops, fire walls, and fire doors, are tested to determine the fire resistance rating of the final assembly, usually expressed in terms of hours of fire resistance. For example, 3, 1, 11, 2, 3, 4 hour. A certification listing provides the limitations of the rating. Contrary to active fire protection measures, passive fire protection means do not typically require electric or electronic activation or a degree of motion. Exceptions to that particular rule of thumb are fire dampers, fire-resistive closures within air ducts, excluding grease ducts, and fire door closers, which must move, open and shut in order to work, as well as all intumescent products, which swell, thus move, in order to function. As the name suggests, passive fire protection, PFP, remains inactive in the coding system until a fire occurs. There are mainly two types of PFP, intumescent fire protection and vermiculite fire protection. In vermiculite fire protection, the structural steel members are covered with vermiculite materials, mostly a very thick layer. This is a cheaper option as compared to an intumescent one, but is very crude and aesthetically unpleasant. Moreover, if the environment is corrosive in nature, then the vermiculite option is not advisable, as there is the possibility of water seeping into it because of the porous nature of vermiculite, and there it is difficult to monitor for corrosion. Intumescent fireproofing is a layer of paint which is applied along with the coating system on the structural steel members. The thickness of this intumescent coating is dependent on the steel section used. For calculation of DFT, dry film thickness, a factor called HP/A, heated perimeter divided by cross-sectional area, referred to as section factor and expressed in M1, is used. Intumescent coatings are applied as an intermediate coat in a coating system, primer, intermediate, and top/finish coat. Because of the relatively low thickness of this intumescent coating, usually in the 350 to 700 micrometer range, nice finish, and anti-corrosive nature, intumescent coatings are preferred on the basis of aesthetics and performance. It should be noted that in the eventuality of a fire, the steel structure will eventually collapse once the steel attains the critical core temperature around 550 degrees Celsius or 850 degrees Fahrenheit. The PFP system will only delay this by creating a layer of char between the steel and fire. Depending upon the requirement, PFP systems can provide fire ratings in excess of 120 minutes. PFP systems are highly recommended in infrastructure projects as they can save lives and property. PFP in a building can be described as a group of systems within systems. An installed fire stop, for instance, is a system that is based upon a product certification listing. It forms part of a fire resistance rated wall or floor, and this wall or floor forms part of a fire compartment which forms an integral part of the overall fire safety plan of the building. The building itself, as a whole, can also be seen as a system.